OBS. Hello. Hello students, welcome to Wallah English channel. In this session, we'll be focusing on the second chapter of theory of computation. In previous lectures, we have completed regular languages successfully, but all the basics which are required to understand the subject we have covered in the class, and so many topics we have covered, like how to write a regular expression, how to design a finite automata, what is the difference between DFA and NFA, and how to identify the languages which are regular and non-regular, also how to write a regular grammar, right? So we have seen even including closure properties of finite languages, infinite languages, regulars and non-regulars. In this session, we'll be starting the next chapter, which is the context-free languages, in which the first topic is context-free grammars. Okay, but you remember that the regular grammars we have already learned. Now the extension to the regular grammars, we are going to focus on the context-free grammars. What is there in the context-free grammars? We will begin with the grammars, then we will go for again what's regular grammar and what is linear grammar, and then we'll come to context-free grammar. So we are going to focus on mainly on context-free grammar, but the part of the context-free grammar, other grammars also cover, like regular grammar and linear grammar, and what is the relationship between all these three grammars we will be learning in this session. Okay, so let's begin with the grammar. Okay, so what is a grammar? You already aware of it, right? What is a grammar? Let's say grammar, G is a grammar. We always represent using 4 parameters, VTPS. Okay, what is V here? We represent. What is V here? V represents set of variables. Maybe you can assume as a symbols, or mainly we will assume here the non-terminals. Okay, assume that terminals are not there in these variables. And T represent the set of terminals in general, but not necessary that the way that we describe the terminals we represent with the lowercase and the variables we represent with the uppercase letters. But in general, this is for the most of the grammars we follow. But in case if they give the terminal as a word like ID is having 2 letters, but we represent as a 1 terminal. And variables also you may represent like a word, program. So program you can either you can represent like a variable. So in general we represent with 1 letter, uppercase for variable and lowercase for terminals, but this may not be always. Okay, yeah, good evening Seema, good evening Prabhakar. All right, how are you all? We know this is right. Now P represent the set of rules, productions. Okay, each production in the P we have a restriction that depends on the type of grammar. Okay, and S represent a start symbol. S represent start symbol. We know this start symbol is belongs to V only, right? S is belongs to V. Now how each production is framed or restricted, that depends on the type of grammar. Okay, in general what grammar does, a grammar is going to have the set of productions, and these productions will help us to generate the set of strings, and that set of strings called as a language. So grammar is basically represents a language. Okay, it represents a language with help of the set of productions. It represents a language. Okay, so this is the definition of a grammar. Now we know what is regular grammar, right? Let me compare that. We have various types of grammars, like regular grammar. If you have remembered that we have studied regular grammar as 2 types. Either it can be left linear grammar or it can be right linear grammar. If it is left linear grammar, we have a restriction how to write every production in the grammar, right? What is the rule for left linear grammar? Have you remembered what is the rule for left linear grammar? For the left linear grammar, the rule is the left hand side is one non-terminal only. Here even you see left hand side one non-terminal only, but right hand side you will be having either no non-terminal or maximum one non-terminal, right? So that is, if you don't have a non-terminal, that's simply called as T star. Or you have, if you have a non-terminal, that should be in the first position followed by any sequence of terminals. So this is the rule for left linear grammar. The production is either in the form of T star or in the form of VT star. So we have two kinds of productions in the left linear grammar. Correct? Oh, right. So have you missed that lecture? Left linear grammar is nothing but left linear grammar. We have already studied it. Okay? Just I am revising it. It is not important at this moment, but I'm just revising the topic. Okay? RLG represent right linear grammar. These two grammars are called as regular grammars only. Okay? If the grammar is LLG or RLG, that grammar is definitely called as regular grammar. Okay? If the grammar is in this form, it is regular. Even it is in this form, it is regular grammar. Okay? Now, if it is right linear grammar, you can have any sequence of terminals, or if you have a non-terminal, that should be at the last. Before that, any sequence of terminals. So the production will be either in this T star form or T star V form. So this is the right linear grammar restriction for framing each rule in the grammar. Now, this we already know it. Now we are going to learn other two types of grammars. One is linear grammar. So what is linear grammar? What is linear grammar? You know, one you have left linear, other you have right linear, and there is another kind of, the main grammar is called as the linear grammar, which has no restriction where the V is. Here V is at leftmost, here V is at rightmost, here V anywhere can be present. So the rule is very simple. The left hand side is same, but right hand side V can be anywhere. But you can have any sequence of terminals, or if you have a non-terminal, that can be anywhere. So before, after, any sequence of terminals can present. So this is how you can frame a linear grammar. Okay. So linear grammar can have any sequence of terminals like others, but if you have a non-terminal, that can be anywhere. It can be first or last, anywhere. But here it should be first, here it should be last. Here it can be anywhere. That's all the restriction in all the three grammars. Left linear, right linear and linear, all the three types of grammars, at most one non-terminal in the RHS side. But how it appears? If it appears always in the first position, that is the left linear. If it always appears in the last position, that is the right linear. If doesn't matter, anywhere it can appear, that is the linear grammar. So by looking at these definitions, every left linear is a linear grammar, every right linear is a linear grammar. So you can write a lot of important points here. Okay, you can write a lot of important points. What are they? The first point is every LLG is linear grammar. In fact, regular grammar. You can say regular grammar. First regular grammar, let's say. And every RLG is also regular grammar. RG means assume it is a regular grammar. Okay, LG means assume that linear grammar. Okay. Now, based on this fact, you can say whether it is LLG or RLG, you can call it as regular grammar. So every regular grammar, you can call it as linear grammar. But linear grammar, no need to be regular grammar. So this is a very important point. Really, video is lagging. So let me check that. Okay. Give me a second. I think video is fine, right? For me, it looks fine. Connection is also excellent. Okay. Just cross check. Is anybody facing the same issue like Seema? Okay. Now, if you look at the examples, I'm just writing here. Suppose I have A, S, B or epsilon. So this is not a regular grammar. What is not? This is not regular grammar. But what is it? This is not a regular grammar. In fact, it is not LLG, not RLG, but it is linear grammar. It is linear grammar. So this is a very important point. This is a very important point. Okay. Second example, suppose sometimes we write S derives AS or SB or epsilon. Now look at this grammar. See here you have last, here you have first. This is not regular grammar. Why? You cannot call this a left linear grammar. You cannot call this whole grammar is not right linear grammar. So this is not a regular grammar. Again, this is a very important point. It is again not regular grammar. We are not talking about the language. We are talking about only the grammar. Grammar is not regular, but this grammar is a linear grammar, because sometimes it can appear left, sometimes it can appear rightmost. But in left linear grammar, always left. In right linear grammar, if non-terminals are always right. But this is not a regular grammar. This is not a regular grammar. Okay, very important point. Okay, languages, we will see it soon. Sima, I'm not talking about languages. I'm talking about type of grammar. Okay, language generated by this grammar, we will see it soon. Here only to understand what is the difference between linear grammar and regular grammar. Now we are going to start. Okay, if I have an example, let's say S derives SA or SB or epsilon. Oh, this is a regular grammar, but before that it is left linear grammar. What is it? Left linear grammar. So you can call it as regular grammar, and hence it is called as linear grammar. Okay, are you able to understand these points? It is left linear grammar, hence regular grammar, so linear grammar. Now let's come to the actual topic, context free grammar. What is the name called as context free? Context free, right? So now here it's a very simple to represent this context free grammar. It helps us to represent the syntax of the programming languages. That's why we call it as context free. And left hand side is a non-terminal, right hand side you have no restriction at all. Here anything, basically anything means here V or T whole star. Of course you can write V plus T whole star. So V union T whole star. That means LHS is restricted to exactly only one symbol, that to non-terminal, and RHS has no restriction at all. So this is called as context free grammar. Every production, the context free grammar will follow this restriction. Now when you look at all the three definitions, right? All the three definitions, now you can say every regular grammar you can say context free grammar, no doubt about it. And not only this, every linear grammar also you can say that context free grammar. But context free grammar no need to be regular, context free grammar no need to be linear. Example, let me show you that example. Some examples I am showing. Suppose I have a grammar, let's say SS or epsilon. This grammar is not a linear grammar because you have two non-terminals, but this is a context free grammar. You can have anything right side, no restriction at all. But if you are talking about regular grammar, it must be LLG or RLG. If you are talking about linear grammar, you should have only one non-terminal max in the RHS side. So this is not going to satisfy regular grammar, this is not going to satisfy linear grammar, but it is context free grammar. Okay, it is context free grammar. Okay, this is not a regular grammar, this is not a linear grammar, but it is the context free grammar. And remember that one point, the language generated by this grammar is just one string. A language generated by this might be regular, but this is not a regular grammar. Okay, very important point. The grammar is not regular, but whatever it does, it is going to be a regular language for this example. Okay, so we'll see that soon. And look at this example, especially this example is a context free grammar, but it is not a linear grammar, it is not a regular grammar. Every regular grammar you can call CFG, every linear grammar you can call CFG, but context free grammar may or may not be this RG and LG. Okay, let's understand some of the context free grammars along with regular and linear grammars. The first example, if you have remembered the regular grammars, right? We have done this. What is the language generated by this grammar? What is the language generated by this grammar? Let's say L1. What is this language generated by this grammar? The first problem it is, right? It's just A or epsilon. And order doesn't matter because it is a set. Set is always an ordered collection. And we already seen, just I am repeating this slide. S derives and SA or epsilon. What is the language? Just find out what is it. Okay. So I'm writing the question, just find out what are those languages. S derives SA or A. 4. S derives AS or epsilon. 5. S derives AS or A. We have already solved these questions. For understanding, I'm just revising so that we can start with the new grammar soon. What is the language generated by this one? If you have remembered that recursion concept, right? E is going to repeat and epsilon is going to stop the S. So epsilon A star is nothing but A star. We know that. Correct? Yeah. And what about this one? That A comes before A star. So this L3 is equal to A plus. And the fourth grammar, that is, let's say L4, and it's going to be A is repeated and epsilon comes after A star. So that's going to be A star. And fifth one, A star and followed by A will become A plus. So in the exam they may ask, they might give you the second as a question, and you need to identify the option equivalent to this one is going to be the fourth one. So the fourth one and second one grammars are different, but they are equivalent because they generate or they represent the same language. Okay, the grammar second one and fourth one equivalent, and 3 and 5 are equivalent. Okay, so it's very important to understand what do you mean by equivalent grammars, because they generate the same language. That's why equivalent. The grammars are not same, but they are going to generate the same language because they are equivalent. Okay, now some other examples we have already seen earlier. Let's look at them. Have you remembered this grammar that we have studied in regular grammars? Okay, just cross check whether you have remembered or not. If you have remembered, just tell me the answer quickly. What was the answer for this? Okay, you are aware of this grammars. They are very famous grammars and very important to remember them for the exam point of view, especially exam point of view. They are very, very important for exam point of view. Now, what is this? Each language represents. Each grammar represents some language, right? What is that each language? Here it is A plus B whole star. In case if you have not remembered this, so you should aware of that. It can generate any string over A comma B. That's correct, Sima. Yes. And now L7, which is A plus B whole plus, because epsilon now you can't generate, but any sequence you can generate. So whenever you see this one, it will give you A plus B whole star, but A or B comes before A plus B whole star. That's why it's A plus B whole plus. Now this eighth language is again A plus B whole star. It means the L6 and L8 are same because the 6 and 8 grammars are equivalent. And L9 is A plus B whole plus. So it is very important what is the language represented by each grammar. These 9 examples are very, very important, and they are going to be basics for you all the time. Whenever you revise the concepts of the context-free grammar or regular grammar, these 9 examples should be there with you all the time, because any bigger grammar that you see, they might be using these 9 concepts. Okay, let's focus on the very important examples now. And now we are going to start a new example, that is S derives A, S, B or epsilon. And what is the language generated by this grammar? Can you guess? What is the language represented by this grammar? And focus on, when you look at the first time, right? So focus on the strings. What kind of strings it can generate? So when you look at the first string, minimum string, that is epsilon. And next minimum string is just A, B. And if you try next string, it's going to be double AB first, and S again it can generate AB. So A, double B. And next if you try another string, right? A, B, B, B. So now when you keep on doing it, right, you will observe the strings in the form of A power n, B power n, where n is going to start from 0. So the language is going to be A power n, B power n, such that n is going to be at least 0. and very famous grammar to know this is a power n, b power n. And using this concept, why it is a power n, b power n? Because this a and b is going to repeat equal number of times. Equal number of times. When it is repeating equal number of times, if 100 a's are going to come, then definitely there are 100 b's will be there. You can see that if there are triple a here, then definitely there will be 3 b's consecutively at the end. Because one a is going to connect with the one b at the last, like this. One ab here, another ab here, another ab here. So this is how it is connected when you generate the strings. Now using this concept, you can answer a lot of questions if you are aware of this concept, right? You see how you can do that. ASB or A 12. You can directly write the answer. No need to worry about all the strings now. B. And if I give you ASB or AB, so can you write the answers directly? What are they going to generate? You don't need much analysis if you can understand 10, 11, 12, 13, which comes from derived from this 10th concept only. Okay, what is the extra that you see? Minimum is A. Minimum is A. And next string is, instead of epsilon, now you have A. Then this AB in between you will see A. So that what's going to happen, the language, the L11 is going to be similar to that, but you see that a power n, b power n, previously epsilon was coming in the middle, but now a is going to come in the middle. So here a is there. And in fact, you can write some other way, same language, that is a power n plus 1, because the a, right, a means a power 1, which means a power n plus 1, b power n. You can also write this way. Okay, the same one, n is greater than or equal 0, but a power n plus 1, b power n. And look at here, who is going to be extra here? B is extra. So a power n, b power n plus 1 or 1 plus n, both are same. And where n greater than or equal 0. Now this one, L13, what's going to happen? A power n plus 1, b power n plus 1, where n greater than or equal 0. But now you can change the concept here. Both are n plus 1, right? Instead of starting with 0, you can also start with 1, but then the converts into power n, where n is, instead of starting with 0, now it will start with 1. That's all. Okay. Okay, that's the first one, right? Clear? So these are the very basics for the concept that we discussed in the 10th. Okay, let's focus on other kind of concepts. 10, 11, 12, 13, it's not at all difficult, but once you have understood 10 and 11, 12, 13, you can write on your own just by observing the strings. Okay. 14. Now it is your target to understand what does this language represents. Okay, A S A or epsilon. Okay, just try them. Same kind of grammar I'm using, not using anything else. Okay, ASB, epsilon 16. S derives ASBB or epsilon, and 17. Okay, very interesting examples that you have here. Can you try them on your own? Very, very easy and important for the exam point of view. First one, very good. A whole star. It looks like the language is a power n, the 14th language, right? It looks like a power n, but a power n is a power 2n. That a power 2n is here actually represent even number of a's. Okay, even number of a's. So that is final goal is very important. The grammar is not regular, but language generated by this is going to be regular. Okay, very interesting question. Next one, what is L15? Can you try this? Okay, take a few seconds to answer it. Every time you generate the string, initially epsilon is there, but every time you generate other than epsilon, that you will see if there are 100 b's, you will see 200 a's, because every b requires 2 a's in the beginning. So what happens here? It's not AA star b, it is going to be, if there are n b's, then you will be seeing here a power 2n b's. But instead of writing this, you can write other way. If there are n b's, then AA comes n times exactly. Right, this AA comes n times. If there is a single a, then a comes n times. If you have AA is there, AA comes exactly the same number of b's. Now this can be written as a power 2n b power n such that n greater than or equal 0 as a set form, okay. A power 2n, if there are 100 b's then definitely 200 a's, because every b requires 2 a's, okay. If there are 100 b's then 200 a's definitely be there in the string. Okay, now here just opposite, if there are 100 a's then 200 b's will be there. Now the connection is going to be, b's is going to be twice. Now if a is coming n times, then b will come twice of the a's, so that makes the b's are going to be twice, your a's is going to be twice. Okay, now when you look at this two, right, and both are going to be having equal time, no doubt, but that's going to be even count. If that a is never be going to be like 3, 5, 7, a should be like 0 time or 2 times or 4 times. When a's are going to be coming like even times, then b's going to come equal number of a's. So L17 you can simply write a power 2n, b power 2n. Okay, if you don't want this, you can also write as like a power n, b power n, such that n is equal to even. Of course, even should count, even should start with 0 here. So this is very important, and the power is very important. You should represent equal time. Don't write star here. Don't write star here. We both should be equal time, and that should be even. So either you can write this way or this way. Both will give you same set of strings. As you see in this set and in this set, you have the same kind of strings. Okay, so these are very interesting examples for you, and let's see one more interesting example. Okay, 18, and carefully look at this example and try to understand what it can do. Okay, can you try to understand what can be done? And if 18 you understood right, then 19 is just copy paste, but similarly you just focus on what it does. But before this, first understand 18, then directly you can answer what is 19. And in fact, this year gate question had the similar concept in one of the grammar. So this is the very famous grammar. Now I'm just keeping 3 star as it is asked twice so far in the gate, this kind of model question. Okay, so what can be done? Just try the strings. What happens to the strings? Epsilon you can generate, 1a you can generate, 2a you can generate, 1b you can generate, 2b you can generate, but also a and b you can generate. It's not a plus b whole star. ba you can't generate. Ba impossible. Try. B always comes at the end. You never start with the B at all. Here, see that epsilon you can generate, A you can generate, B you can generate, W you can generate, AB you can generate, but BA you can't. That means there is something which is hiding in this grammar. That concept is needed. So when you are able to understand the concept, see this production, A comes in the first position, see this production, B comes at last. That means if you have taken this, that means you are keeping B at the last. If you are taking this, you are keeping A as the first. So if A's and B's are coming together, A's will come first and B's will come later. So if you look at this strings, right, if I want let's say 2 A's 3 B's, is it possible or not? Just check it. 2 A's, because A, yes you can take, again A, S you can take, S, B, S you can take, again S, B, S you can take, this S you can just take, sorry, B, S is not there, I'm very sorry, S, B only, right? S, B is there, and this S you can take S, B, again this S you can take S, B and epsilon. So 3 A's and then 3 B's. So you have to take like this, 3 A's, okay, sorry, 2 A's and 3 B's. So how did you generate this? When you are generating it, what's happening? S you substitute with AS, so first A comes, again S you substitute with AS, so first A's comes. When you want B's, what happening? That B goes, S you replace with SB, not BS. Now B's goes to the last, again the B is there, again SB, again you put one more SB. So now at this time you put epsilon, so double A triple B. It's impossible to get B's first then A, right? So here you should understand one thing. When you look at this BA is not possible to generate. BA, see, if you go here A comes first, if you go here B comes last, but it is not possible to generate the B first then A next. So when you look at this, right, the language is going to be any number of A's first followed by any number of B's you can get. So that is A star, B star. So this is what the importance. When you look at the grammar, right, note, I'm just keeping a note. I never confuse with this example. S derives AS, BS or epsilon. This will generate A plus B whole star. And when you look at this, the first one, and note 2, when you look at the grammar AS or SB, look at that, almost looks like same, but there is small change here that you need to observe, and this makes there is order between A's and B's. That's A star, B star. Okay, both are going to be different grammars and they will generate different languages. Okay, why not B star, A star? Why not? Just you look at, right, can you generate BA first? Come on, Seema, can you generate BA? If you can't generate, how can be B star, A star? Very simple, right? In 18, you can't generate a BA. You can't generate a BA. You can't generate B's followed by A's. You just try it, no? You have the grammar in front, and why don't you try it? Right? I've already given some examples. You did not understand, just try many ways. Many strings you try, up to go for 3 length and understand what strings you get it from here. Unless you don't understand the strings, what it generates, you don't know what is the language. Look at that. Every time you don't get a shortcut. Now look at this. At least try up to 3 length to get the idea what is it happening. Now look at epsilon A, B, double A, B, but BA is gone. And double B, yes. Triple A, yes. A, B, yes. Now A, B, A. Try it. Impossible. A, B, B, yes. B, double A, impossible. B, A, B, impossible. B, B, A, impossible. But triple B is okay. Now look at the strings. If you try each one, you will get to know if A's and B's are both are coming, then B will never come in the first. Okay, only B's are coming, it's fine, because this can generate only B's, this can generate only A's because by repeating it. But when the together both are coming, see, just understand here, A, yes, and S, B. S you put with this, the B goes last. If S you put with this, A comes first. That means there is order between these two productions, that A's comes first, B's comes at last. Look at these two productions only. You get the idea that A's comes first, B's goes last. That means see that AS, SB. See that A's goes first, B's goes last. You take any order. See SB you take first, then AS, replace it. See, this S when you replace with AS, right? A's comes first, B's comes last. Doesn't matter which order you follow. The first A's only comes, then B's will come, and both are there. So that is what you require to understand. And first, put enough time to understand this grammar, because in future you may face a lot of times. Then you should not confuse what grammar it is. Now look at this. When you look at this, right? Oh, B's are coming first, then A's are coming at the last, then answer is over. Then by looking at that concept, this is L18, right? Then L19 is going to be B star, A star, over. That's it, right? Only one concept is needed for you to understand what kind of grammar it is, okay? So this is one of the important gate models so far in the exam, okay? 20. S derives AS, SB or A. Now focus and answer your question. Try to answer for this question. Okay. Now I'm doing something else. AS, SB or B. What happens when you write this one? Now definitely one A is there, but these sequences will not going to change. This will help you to get A star, B star, like A star first, then B star last. But who comes? E is going to come here like this, here or here. That means A comes here. So what is the language that is going to be? It's going to be A plus B star. There is definitely A comes in the same sequence. It's like A star, B star only, but A is always there in between. Okay, now similar way, you look at this one, that this together will tell you A star, B star only, but this B is going to come in between the B is going to come. So L21 is going to be A star, B plus. Okay, it's very important to understand. It is very important to understand what is the language are generated by this kind of grammars. Okay, Even see that the beauty of this kinds of grammars, and within almost 30 to 40 minutes we are able to solve nearly 21 questions as a beginner, right? So look at that. If you are able to practice this context free grammars, right, 1 or 2 marks, or most of the times I see in the PYQs, gate PYQs, the context free grammar, at least one question will be there. So you can practice this kind of grammars to get the awareness. Okay, let's try one important question. 22. Suppose I have S derives AB and A derives AAB or epsilon, and B derives, let's say, CB or epsilon. So how do you solve this question? Always focus on this grammar. You need to focus on bottom to up. When you generate bottom to up, so first let's understand what is B, what is A, then put in S. So that answer will be very easy for you. What is that B generates? If you look at the B, right, B is going to be, it's a C star, right? What B generates? Just C star. And take this C star and put in S later. And what is A is going to be? A is going to generate A power n, B power n. And you know about A, you know about capital B, then put both of them in the S. That is going to be your language. So what is your language now? Your language, that's 22, right? It's whatever S generates, whatever S generates. What is S generating here? A followed by B. What is A? A power n, B power n. What is B? C star. So now this is going to be your language. A power n, B power n, C star, such that n greater than or equal to 0. Maybe you can write many other ways, that's fine. A power m, B power n, C power k, such that m comma n comma k greater than or equal 0 and the m is equal to n. So you can also write this way. Correct? So there are very interesting grammars are there to practice. So I want you to practice on your own such grammars. Okay, let me give you some questions for practice. Okay. Now practice these grammars. Okay, assume this is a 23 example, but practice these grammars, and which really helps you to understand. Now first one, similar to the previous one, S derives AB and A derives A or epsilon, and B derives A, B, B or epsilon. This is the grammar, right? So you require to identify what is the language generated by this. What is the language generated? Let's say this is a G, and what is L of G? Okay, here are options I am providing. Option A is, let's say, A power n, B power n, such that n greater than or equal to 0. Another one, A power m, B power n, such that m not equal to n. Nothing is mentioned, means m comma n greater than or equal to 0. A power m, B power n, such that m greater than or equal to n. In fact, m comma n greater than or equal to 0. A power m, B power n, such that m less than or equal to n, where m comma n greater than or equal to 0. So try to practice this question and understand what language it is generated. You can also eliminate the options, right? Yes, is that Raviteja? Yeah, how quickly you are able to answer it, because you understood the concept, right? That's all enough for the exam. So you don't need much effort for the TOC questions. The basics you need to put an effort. When the problem comes, you can solve within seconds. That is the beauty of the theory of computation. Okay. Question 2. Okay, S derives, okay, I'm just saying it is a G. S derives, let me write some different grammar for you. ASA or BSB or epsilon. I didn't explain this grammar, but this is a very different grammar. Okay, very different grammar. And what is L of G? Understand the options and try to look at what is possible. Okay, don't answer blindly. You need a clear understanding of each question here, each string here. The first language, let me write something like A power 2n, B power 2n, such that n greater than or equal 0. Okay, otherwise let's say W such that W belongs to A comma B whole star. Or let me write another way, W power R such that W belongs to A comma B whole star. T W such that W belongs to A comma B whole star. Okay. It's a very famous grammar for palindrome concept, right? Is it even length or odd length? Again, it's going to be option yes. C is going to be correct, but just try your own way. Don't ask me the answer right now. Question 3, again, grammar. I'm just giving grammar. S derives A, B, A derives A, B or epsilon, and B derives B, B, C or epsilon. Okay, so this is your grammar. And what is language represented by this G? A power M, B power N, C power K, such that M is equal to N or N is equal to K. Okay, carefully answer it. A power M, B power N, C power K, such that M is equal to N plus K. A power M, B power N, C power K, such that N is equal to M plus K. Of course, you can also write in subtraction form, but that I am not representing here. Okay, in the exam they may try to confuse you by using subtraction also. Here this one can be written as M is equal to N minus K. Okay, understand that. Here K is equal to M plus N. Okay, in all of them M comma N comma K greater than or equal to 0. Very interesting example. And look at answer for each. And what is your another homework is, for each language you try to represent or try to write a new grammar on your own, so you will get more knowledge on grammars. So maybe I have given one example and you need to identify one of the 4 options, but each option there is a grammar correspond to it. So try to understand the grammar, context free grammar for each language, then you get more understanding for that. Okay, S derives A or B, A derives A. Okay, I just want something else here. B or epsilon, B derives double A, B double B or epsilon. Okay, it might be so simple, but you need to focus on what exactly the strings are. Not all the times what you think, right? Sometimes you need to simplify the language. You know, A power N, B power N, such that N greater than or equal to 0. Another example, A power N, B power 2N, such that N greater than or equal to 0. Other one, A power 2N, B power 2N, such that N greater than or equal to 0. And there is, you have the none of this, so you should be very careful before going to none of this. There might be option, there might be correct answer in one of the first 3 options. Okay, the option, the A capital A is generating the equal A's and B's, that's A power N, B power N. Capital B generating A power 2N, B power 2N. But when you look at in the language, when you do the union, what happens here? Because A or B means A union B, right? Yeah, option A, correct, exactly. Okay, let's go for very lengthy grammar as the last one. S derives A, B, C. Okay, A derives A, B or epsilon. B derives B, B, C or epsilon. And C derives, this is a small c and this is a capital C. Okay, and C, B, D or epsilon. Okay, now you need to identify the language. I'm not giving the options for this. What is language represented by grammar. Okay, so you can get a lot of options I can give you, but not required. Just based on the previous examples, find out the right answer for this. Assume it is a fill in the blank, find the right answer for this. Okay, you need to identify language represented by the grammar. Okay, so no options for this. You need to focus on what exactly the language and write in the options. Okay, what is the right language generated by this for this grammar. You can observe here A, B is there, here B represents B power n, C power n, and when you write in concatenation, right, you should be very careful. It's okay, even B is there, it's fine. If you want to take the C, that you can take, but still you can find, you just go home and then try with the B. So that is also possible to answer it. Okay, it's fine. C still, okay, don't assume that the C is there, but it's fine. See, B is there, still you should know what is the answer for this, right? No need to be C. What happens? Okay, what happens when it is, you need to identify, right? What happens when you do it? See, B we don't know, right? So B get to know, B you will get something like B power, let's say K, C power K, and take that and put here, because you want to know the answer, right? Then C, B power K, so this together are coming, so don't put a K, put something else, let's say N. Okay, you should be very careful when you do this, because these two are going to come in the same sequence. So don't write the B power K, C power K here, write B power N, C power N, and what A happens, and don't write K and N, just write something else, let's say A power M, B power M. Just put them in the sequence, then you'll get to know some concept here, right? Very good observation here. So take this B only, don't take the C. C means repetition, but B is not a repetition. You need to depend on other non-terminal. It's like other function call. Okay, so take care of this different things and try to, anyhow, almost I answered it. Just put them in a sequence and find out what language you get, that you can easily answer it. Great. Yeah, thank you so much for attending today's session. Okay, we'll be seeing in the tomorrow and the next session about the push down automata basics. Okay, so we are keep on going for the till the end, but we'll purely be focusing on basics, and you should not require any kind of the knowledge before coming to these classes, because we always start from the basics, but we may not go to the advanced, but we will have the advanced concepts in the class itself. When you are not able to understand any concept, you can comment in the below video. I'll be replying to you whenever I get the time. Yeah, thank you so much for attending today's session. See you, take care, bye bye.